Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you've come to the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. I'm going to talk about open and closed sets in the plane. Now, sort of the audience that I imagine that would watch this would be somebody who is in near the beginning or middle of a Calc 3 class where you are getting ready to talk about multivariable functions and then leading into partial derivatives. That said, open and closed sets. You've heard of open and closed sets in the context of intervals, say in a pre-calc class, or Calc 1, Calc 2 even. So for example, if I use this notation right here versus this one, right? So this one represents the interval from 0 to 1 where I exclude the endpoints, and this one would be the interval from 0 to 1 where I'm going to include the endpoints. What that means on the number line is I would have, let's say, from 0 to 1. Remember, excluding, we put, say, an open circle, and we put an open circle, or in other words, I guess it's using the word open two different ways there, but a circle that I don't scribble in, and we could even just kind of delete part of that. Maybe that'll kind of help indicate, and then we scribble in between. Now, for the interval 0 to 1, where this is including, we call this a closed interval, and we indicate that by scribbling in or closing in the circles, and then scribble in between, right? So we say that this is an open set, or an open interval, and we say that this one is closed. Well, in Calc 3 and lots of other courses, right, we're going to be concerned about regions in the plane, or R3 and 3 space, 4 space, so on and so forth. I'm going to focus more on the plane in this video simply because it's easier to draw. But we might have some region and we want to describe, is it open or closed? And so what sort of features do these have that the same thing will happen in R2 or R3? Because we could have much more complicated shapes than just intervals. Well, before we kind of get into that, let's look and see what the difference between these. Well, open means it does not include the endpoints. Closed means it does not include the endpoints. And to use a term that I used in a previous video, the open interval does not include its boundary points, whereas the closed interval in this case does include the boundary points. So let me go ahead and give a definition for open and closed regions in the plane. So definition. Put more ink in that. Okay. A region, let's call it D in R2, is open if every point of D is an interior point. And I suppose at this point, oh my gosh, pun intended. At this point, I probably should have mentioned that before you watch this video, you should watch the previous video, or a previous one that I posted, I don't know, yesterday or the day before, where we talk about interior, exterior, boundary, and limit points, because I'm going to use that terminology here to discuss these open and closed sets. So a region is open if every point of D is an interior point. So let's go ahead and get a sketch of what that would look like. Okay, so in the interval notation, or well, on in the number line, to exclude the endpoints, we just put these open circles. But if I have like a circle or a disk or some sort of blob, I can't just put like little open circles all around it. So what I do is I use a dashed line. So the convention is that a dashed line is not included, same way that these open circles, or non-colored in circles, however you want to say that, is means the same thing. So then I'll go ahead and I'll scribble everything in here, and we'll say that this is an open set or an open region, something like that. Well, how does that relate, again, to the definition? This says that every point is an interior point. Well, if I pick a point, let's say, I don't want to use the blue. I don't think blue's dark enough or light enough. Let's say I pick this point right here, right? So that little dot. Is that an interior point? Well, so it's away from this dashed line. So what I could do is I can actually put a little disc around it. And that disk is completely contained inside of the region. And of course, if I get close, you know, the whole game, if I get closer, then I'll just make a smaller disk around it. So if I say, all right, well, how about this guy? Yeah, okay, well, then just make it even smaller. And if I get closer, I can just keep making the radius of that disk smaller and smaller. But every single point is an interior point. Therefore, it is an open set. All right. So there's the idea for an open set. Now let's talk about a closed set. So definition. A region D in R2 is closed if it contains all of its, what do you think? Probably said boundary points. It's limit points. Okay, so it's closed if it contains all of its limit points. All right, so let's go ahead and take a look at a region. Let me see if we get a rag here to erase part of this. So let's go ahead and get rid of this part, and let's look at an example, or just a general idea first, and then we'll look at a specific example of a closed region. So if I want to talk about a closed region, let's do two. Let's do one that is closed and one that's not closed. So for example, again, let me do two sketches. Actually, no, I think this one, what color did I use over there? I think it might have been this guy. Let's try. That looks more like it. Sometimes it's hard to tell what marker colors are going to show up well on the screen versus what I'm writing on. Sometimes there's like a dark blue that I think looks good here, but then when it comes up on the video, it's not as good. So I try not to use that as much. So why am I holding on to it? So let me go back here. So the convention is that a dashed line is not included, but if I want to include it, right, like the closed in circles that were scribbled in, we used a solid line. So let's say I wanted to do something like that, and again with everything inside included, versus if I wanted to do something like that, where it's maybe this part of the boundary is included, but then that part of the boundary is excluded. Well, this one over here is going to be closed, and this one is not closed. Okay. In particular, this one has a variety or a whole section here of limit points that are not in the region itself. And again, when I said the definition, I sort of anticipated, and I can't read your mind, I don't know, that's not a thing, right? But I sort of anticipated that you were going to say boundary points, just because I mentioned that word over here when we talk about the intervals. Well, these points along here, these are limit points of the set. And these aren't boundary points. Well, I guess in this case they would be boundary points, but the idea is that if I take a point here and let's say that's on the dashed line, so it's not included in the set, that is a limit point because every single disk centered around that, no matter how big I make that radius, includes both parts, includes at least one point of the region. So therefore it is in fact a limit point, but it's not in the set, so therefore it is not closed. Okay. So now what I'm going to do is let me take a specific example of a of a region. And what we'll do is we'll get a region in the context of, say, finding the domain of a function, and we'll see if we can classify it as open or closed. So let's see. Get this all cleaned up here, and then we'll take a look at, for example, see, this is a color I'm not 100% sure about. Does that show up okay, or is that hard to read? Because I feel like here it looks okay, but then when I look on the other screen, it looks kind of harder to read. So let me see if I can just start writing it, and then I'll just leave in the comments below if this red marker, if it shows up, or if it's kind of hard to read. So let's say I've got this function f of xy is equal to, yeah, I'm guessing you guys are going to say that's not easy to read. So I'm just going to write it for the function, and everything else I use with different colors. So let's say f of xy is equal to the square root of 4 minus x squared minus y squared. So 4 minus x squared minus y squared, all under the square root. What I want to do with this is let's find the domain and classify as open, closed, or neither. Right? Here, let me pause this, and then I'll erase it. All right, here we go. So solution. Now, when we find domains of multivariable functions, remember that the restrictions are the same as for single variable functions. We can't divide by 0. We don't want any negatives under square roots. We don't want any negatives or 0 under a logarithm. So things like that. In particular, for this one, we know that the expression 4 minus x squared minus y squared has to be greater than or equal to 0. So if I take both of these terms here and I put them on the other side, I get 4 is greater than or equal to x squared plus y squared. And, you know, this is a inequality in two variables, so I can't solve it like we can in pre-calc, right? I can't find, say, an interval or something, because this is going to be a region in the plane. Well, if I'm going to change this back, but let's say this was an equal to sign, right? I really hope I don't forget to change that back. Light me up in the comments if I do. So 4 equals x squared plus y squared, that is an equation that should look familiar, right? That right there is the equation of a circle of radius 2 centered on the origin. Remember, it's radius 2 because this side is the square of the radius. So if I plot on this coordinate system here, if I go 2 units and then I draw the circle of that radius, it looks like this. Now, yeah, I'm going to save myself so I don't forget to do that. You can still light me up in the comments if you want. I don't care. So 4 is greater than or equal to x squared plus y squared. So that means that the value of x squared plus y squared has to be smaller than 4. That means that it is going to be the inside of this. So this is the disk of radius 2 centered on the origin, and notice that the boundary is included because I've got an equal to sign in the inequality, right? So this includes the edge here. Those are all limit points, and therefore this is a closed region. So this is a closed region. All right. Similarly, if I say f of xy equals, let's say, x over y, well, what's the domain of that? Well, it's everything except for when y is 0, which would be the x-axis. So that means that my domain would look like this. I'm going to exclude the y-axis, but I'm including everything above and I'm including everything below. Well, everything in this region here is an interior point. So if I just go somewhere off the y-axis, you say it's up here, or I put a disk around it, it's an interior point. If I get close to that, just put a smaller disk around it, it's an interior point. So therefore the domain here, which is the plane excluding the x-axis, this would be an example of an open set. Okay. Well, thank you for watching, and please consider subscribing.